Hero painted his room at a rate of 8 square meters per hour. After 3 hours of painting, he had 28 square meters left to paint. So after 3 hours of painting, he had 28 square meters left to paint. So they're talking in terms of how much we have left to paint, not how much we have painted. Let A of t denote the area to paint, A measured in square meters, as a function of time, t measured in hours. So A of t, once again, this is how much we have to paint, not how much we have painted. Write the function's formula. So what I like to do is, let's just think about a couple of points here. Let's just make it a little bit tangible for us. So I'll do this in a different color. So let's think about what A of t is at different times. So this is time. This is A as a function of time. And they give us one of them. They say after 3 hours of painting, he had 28 square meters left to paint. And once again, A of t is how much we have left to paint, not how much we have painted. So I'm going to leave some space here for some other values, maybe 0, 1, 2. Let's write 3 over here. After 3 hours, he had 28 square meters left to paint. We're just assuming that this is going to be in square meters, and this is in hours. Now, they tell us that he painted his room at a rate of 8 square meters per hour. So let's actually back up a little bit. Let's back up. Let's say after 2 hours, how much would he have had left to paint? What would A of t been? Would it have been more than 28, or would it have been less than 28? Well, he's painting 8 square meters per hour. So every hour that goes by, he's painting more. But A of t isn't how much he has painted, it's how much he has left to paint. So he should have less to paint as time goes up. So as time goes up, as time increases, A of t should go down. So at 2 hours, he should have more to paint than at 3 hours. Because remember, A of t is how much he has left to paint. So how much more would he have had to paint at 2 hours than at 3 hours? Well, it tells us that he has 8 square meters he paints at a rate of 8 square meters per hour. So between 2 and 3 hours, he would have painted 8 square meters. So at 2 hours, he would have had 8 square meters more to paint. So if you add 8 to this right over here, you would be at 36. So he would have had 36 square meters to paint at 2 hours. And then what about 1 hour? So at 1 hour, he would have had 8 more square meters to paint. So 36 plus 8, that is 44. And at 0 hours, what would he have had to paint? So let me do this in another color. At 0 hours, well, he would have had to paint 8 more square meters. So 44 plus 8 is 52. Let's think about whether that makes sense. If right when he was starting, he had 52 square meters to paint, then an hour goes by, so your change in time is 1 hour, and then your change in how much he has left to paint, it goes down by 8. Change in A is equal to negative 8. That makes sense. His rate of change should be negative because the amount he has left to paint goes down as time goes forward. So this was pretty interesting. Now let's see if we can actually construct a formula, or the formula that describes this function. Well, this is happening at a constant rate. Every time t goes up by 1, we see A of t goes down by 8. T goes up by 1, A of t goes down by 8. They tell us that, and that's because he paints it at a rate of 8 square meters per hour. So whenever you're describing something that's happening at a constant rate, that can be described by a linear function. And a linear function will have the form A of t is equal to your rate of change times time plus wherever you started. And M and B are just the letters that people tend to use for your rate of change, your slope if you were graphing this, and B, where you started off, and this would be your vertical intercept. Sometimes you call it your y-intercept, but in this case it would be your a-intercept. If we're thinking about the actual, it would help us find the a-intercept if we were graphing this thing. But we actually already know both of these things. We know what our rate of change is. It is negative 8. I mean, we could say, well, what's our slope? Our slope is change of A over change in t. Change in A over, let me write it this way. Let me do it in a different color just for fun. So our slope is just our change in our dependent variable over our change in our independent variable. which is equal to negative 8. They tell us that. It's equal to negative 8. So this thing is equal to negative 8. And b is going to be equal to a of 0. A of 0. Well, when t is equal to 0, this term right over here goes away, and you're just left with b. A of 0 is equal to b. And we know what a of 0 is. It is equal to 52. So we know this right over here is 52. And we're done. We know that, I'll just rewrite it just for fun, a of t, the area that he has left to paint as a function of time is equal to negative 8 times time plus 52. Plus 52. And you can confirm that the units make sense because this negative 8, and actually let me write it one time with the units just because it is an important thing to think about. Area as a function of time, this is how much he has left to paint, is going to be equal to negative 8 square meters per hour. So negative 8 meters squared per hour times t hours. Maybe I'll write out hours so you don't think it's a variable. T hours, let me write the hours over here. T hours plus 52 square meters. Plus, let me do it right over here. Plus, I have trouble switching colors. Plus 52 square meters. And you see hours divided by hours cancels out. You'd just be left with meters squared. You'd have negative 8t square meters plus 52 square meters. And so the a of t is going to be given to you in square meters. Now there's other ways that you might have wanted to tackle this. You might have immediately said, hey, look, my rate of change is 8 square meters per hour. Now you have to be very careful there. You have to say, well, you might have said, oh, my rate of change, maybe it's going to be positive 8 square meters per hour. But you have to be clear that A is not how much he's painting, it's how much he has left to paint. So his rate of change of how much he has left to paint is decreasing at 8 square meters per hour. So you might have said, okay, immediately, my formula would look like this. A of t is going to be equal to negative 8 times t plus some b. And then you could have used this information right over here to solve for b. You say, hey, when t is equal to 3, a is equal to 28. You could have just used this information right over here and substituted right over here. So when t is equal to 3, when this is 3, a of t is 28. And you have gotten 28 is equal to negative 8 times 3, so negative 24 plus b. And then you would have added 24 to both sides. Whoops. You would have added 24 to both sides. And you would have gotten 28 plus 24 is 52. And then on the right side, you would just have b. You would get b is equal to 52, which is exactly what we got over there. I liked to do it this way just to make sure that we really conceptualized, we really grokked what was going on.